This video will go through several practice problems, so right now I would like you to pause the video and try these three problems. So I'm going to write out the answers, and if you get all of these right, good job. You don't need to watch the explanation. If you miss any of them, I recommend that you go back and retry the ones that you missed. And then if you still don't understand what you missed, watch my explanation. So I'm going to give the explanations right now. Like I said, if you got them right, you can just fast forward to the next set of problems. So for number 1, we are going to find the limit of this one by factoring. You'll find that if you substitute in 4, you get an indeterminate form. You get a 0 over 0. So that means that we need to use other methods than just plugging in values. So we do things, we can't just use direct substitution on this one. So in this one, I'm going to factor. And factoring for this one is great because I end up getting this factor x minus 4 canceling out. And now I'm going to be taking the limit of 1 over x plus 4 as x approaches 4. If I substitute that in now, I do get 1/8. And you'll find that number 2 is actually the same process. So I'm going to factor. So then the x plus 3 is going to cancel out. If I substitute in, sorry about the difficulty with my stylus right now. If I substitute in -3, I end up getting -3 minus 2, which is equal to -5. So number 3, there might be people that might have had some issues on this one. If you substitute in 1 for this, if you use direct substitution, you get 2 over 0. 2 over 0 is not an indeterminate form. So actually, you could try to factor this one if you want. You'll still get an indeterminate form. So this one actually is going to be that it does not exist. So for these 3 problems, do the same thing as the previous ones. Go ahead and pause the video, try them on your own. Okay, so I'm going to give you the answers and you can check them. If you get all of these answers right, you can feel free to stop the video and continue on with your homework. If you miss anything, I would recommend that you do watch through my explanation. So for number 4, you should get that the answer is 3. For number 5, you should get 1/2. And number 6, you should get -1/4. All right, so for number 4, we are going to factor this one. This one's really similar to the previous 3. Actually, it's similar to numbers 1 and 2. Only issue is you may have forgotten how to factor a difference of cubes, but there is a formula for that. You might want to look back at your notes from Algebra 2 if you've forgotten this formula. And we end up getting this right here. So I'm going to cancel out my x minus 1, and I do end up getting that my final limit is the limit of x squared plus x plus 1 as x approaches 1, and that gives me 3. So number 5 is fun. That one involves rationalizing. So in order to rationalize, if you recall from the previous techniques on taking limits, you are going to take the conjugate of this square root expression. All you need to do to take the conjugate is change that sign in the middle of the expression. So now instead of a -1, it's going to become a +1. And as with anything, when we are changing fractions, we have to do the same thing to the denominator that we did to the numerator. So we're also going to multiply the denominator by the square root of x plus 1 plus 1. So if you simplify that out, you end up getting x, excuse me, I forgot to put my limit notation in there, don't forget that. You get the limit as x approaches 0 of x plus 1 minus 1. You can use the FOIL method to work this whole thing out on your own. That is all over x times the square root of x plus 1 plus 1. I do recommend that you do not simplify the stuff that you have in the denominator yet. You can in a minute or so if you find that it'll make the problem easier, but actually you'll find that it makes the problem more complicated, gives you an extra step to do. So this is going to, the numerator is going to simplify nicely to x. And you might now see why I told you not to simplify the denominator, because those two x's now are going to cancel out. Okay, so final limit is the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. If I substitute in 0 for x, I do end up getting 1/2. So for question number 6, if you got this one on your own, good job. This is a little bit of a tricky problem. You will find that if you substitute in 0, you do get an indeterminate form. You get 0 over 0. So you need to use different methods to solve this. And whenever I see something that has a fraction in a fraction, my first inclination is to get rid of one of those fractions. So I'm actually going to eliminate this numerator right here. I do that by multiplying by the common denominator. Now keep in mind, I didn't say get a common denominator, I said multiply by a common denominator. So I'm going to multiply this expression up here by 2 times 2 plus x. And if you aren't sure why I did that, you'll see in just a minute, hopefully. Remember, with fractions, do the same thing to the denominator. So now what's going to happen is my numerator, I'm going to distribute this. If I have, I'll show you the intermediate step. You don't need to write all this out, but I will end up getting 2 times 2 plus x multiplied by 1 over 2 plus x minus 2 times 2 plus x multiplied by 1/2. That is the entire numerator now. It's super complicated. Like I said, you don't need to do this middle step if you understand why I'm doing it. Denominator is going to be 2x times 2 plus x. As with the previous problem, I do recommend that you don't simplify just yet. You can distribute in the end if you need to, but it might make it easier to not do that. And now you're going to find that a bunch of things in your numerator cancel out. The 2x plus 2 plus x and the 2 plus x here cancel out. So right there, I'm just going to be left with 2. The 2 multiplied by the 1/2 are going to be 0, are going to be 1, so that also cancels out. So I just end up with 2 plus x right here. And keeping my denominator like that, Now you might see that this problem is a lot easier to work with. So my numerator is going to just become negative x. Denominator is 2x times 2 plus x. And as with the previous problems that you had, I do have something canceling out. So I now end up getting the limit as x approaches 0 of negative 1 over 2 times 2 plus x. Now I can use direct substitution, and I end up getting negative 1/4.